All right, folks, welcome back. We are going to continue our work in Unit 4 this week. Last week we managed to get through the first part of Chapter 3 in lecture form, and we started talking about decision statements, and then looked at if statements, and we got through actually a bunch of these topics here, and I'm going to try to pick up exactly where we left off. So I'm going to log into my ebook here, if you give me just a moment. If I was a little more prepared, I would already have it up on screen, but that's how the days go sometimes. So we just kind of roll with it. All right, so I'm going to start. We had finished up in section 3.4, and I'm going to kind of navigate to that section just to kind of do just a really quick refresher on that topic. So we had talked about if statements, and then we talked about like what happens if you have like multiple things you have to check in order to perform an action, and we got into this multiple if statement approach, where we were dealing basically with a logic like this. If you're looking for a number of different conditions before you execute an action, and that leads to code that can look like this. And this is actually an approach that some people will use. They'll actually spell out else and then put another if inside of it. But Python allows for this combination statement, which I think is a little bit more elegant and basically does exactly the same thing. So instead of spelling out the word else and then having a secondary if statement, in this language we do elif. That's a little odd. That's unique to this language. Most other languages will just combine it and say else if in one word, but it's essentially the same thing. So if you've learned a different language or are maybe learning Java concurrently with this, that won't seem so weird. All right, so that's where we kind of left off, and then we were going to go on to the next section. Before we go to that next section, when I was reading through the chapter, I saw this cool little sending email exercise that they have in here, and this isn't like anything that's required, but I thought for those of you that are interested, this is a great little bit of code for writing a program that actually does send email. And then I think of those that might work on server operating systems in particular, where you can actually like automate some scripts that would send messages out without necessarily needing to bring up an email client. The code is provided, so it's not like this is a difficult one to do. The difficult part of this is actually getting the settings from your email provider and getting them to work. That's the real trick, because you have to relay your email message through their server, and then one thing you will discover is some email providers don't allow for that. Usually the web-based ones like Gmail and Yahoo have a mechanism built in, but there are some systems, and I'm thinking of like Time Warner or Spectrum, where you actually have to attach to their network to send the message. But if you do attempt this one, what I am going to say to you that the part that is tricky basically is getting these correct settings right here, getting the right port address and the right host, and then also being attached to the right network. If you do get it to work, please be kind enough to include a screenshot of the successful message being received. Hopefully you send it to yourself, right, so you can receive it. But I think this is really kind of an interesting little program, and it shows you some of the innate power of Python compared to some of the other languages that we work with. All right, now moving on to the next little section here. They have a little thing on flowcharts, and I know that we've been talking flowcharts kind of the whole time, and they're kind of ramping up their flowchart tools here to include how you work with if statements. And the big, addition in this environment really is the fact that we throw in a condition statement. So really the three shapes that we have available to us so far are basically the square box, without the tilt to it. That's like programming instructions that happen behind the scenes. The input-output box, where you're either getting something from the user or receiving something from the user on the screen. And then the condition box, where we test basically what we call Boolean logic whether something is true or false, and then choose a path of action related to it. So those are the three elements that we have. They kind of reiterate what they were showing earlier in the chapter, that you can have if statements where the true has a pathway and the else or the false has a pathway, and then also showing like the multiple if statements as well. And you know, if you start to take any problem and start to figure it out, there's a good chance if there's a decision statement, it can really help you kind of figure out your logic before you write code. Because sometimes when you're problem solving, you can kind of think through it better in your brain than you can in code initially. So if you can kind of sketch it out like this, what'll happen is when you get to writing your code, it's just going to be easier. That's my way of looking at it. Experienced programmers often kind of skip the flowcharting step unless the problem gets insanely complex. And then, you know what, they go back to this tool for as simple as it is. And you know, sometimes people will do it with computer software, and sometimes they just do it with, you know, pencil and paper or a whiteboard and a marker, and all of those can work pretty well. There are actually professional flowcharting tools out there. You know, probably like the biggest and most important of those tools is a product called Microsoft Visio, and I'm not sure if you guys have ever encountered that. Yeah, and usually in programs like this, we don't really go into it because it is an expensive product. It's not part of Microsoft Office natively. However, if you get into the networking field, you'll find that a lot of people use Visio not only to do flowcharts, but also to do networking diagrams. So, you know, you see people that create like cool little diagrams of like networks with computers and clouds and switches and routers, and that's the tool they use. So just a helpful tip for you guys. I'm going to move on, and you know what, I'm going to kind of take back what I just said. Actually, it is available for you guys through the Azure cloud. We'll talk about that later. Now that I think about it, it is included in there if you wanted to play with it. So I'm not really requiring you to do any flow charting at this point, but I always want you to have that as a tool kind of in the back of your brain. The other thing I want to talk about, and this is once again going to be what I call in kind of a quick format, because we're not actually going to follow through these steps here, but I do want to talk about when you start to write programming logic, especially when decision statements are in place. Here's what often happens. You'll write some code and you think it's right. You think you got all the scenarios covered, and I'm thinking very particularly about like multiple decision statements, and you think, okay, well, if I throw this at it, it should be covered here, and if I throw this at it, it should be covered there, and I think I wrote my code correctly, and all these scenarios will work out just fine. The reality is the only way to really know that your code is right is to actually write some test cases. So what they do, for example, is like they're thinking about that tax income bracket example that they've been working with in the chapter, and you might start throwing values at it thinking that you got it all covered. But the only way you can know for sure is kind of like we did with our, like doing simple math, is you pull out the calculator, you do the math, and then you run the program and make sure the program comes out with the same thing. You do the same thing when you're running multiple if statements. You want to throw scenarios at it to make sure that each one of the scenarios actually works the way you intend it to work. So this is just basically called program testing. And you know, from what I heard from our advisory board, that's a really key aspect of releasing a program prior, you know, to giving it to the public, is they actually do what they call unit testing, where they write code that tests your code. Now that's kind of a mind-boggling concept, but apparently it's really huge in the industry. People that are serious about quality software always do that. You know, so that's a pretty important concept just to kind of keep in the back of your brain. We don't really do a lot of that here because, you know, we're trying to learn the basic concepts of programming first before we get to testing the programming. But what I like about this book is they kind of give you all the concepts so that if you are already an experienced programmer coming in here and learning this language, there's higher level stuff that you can pull from these chapters. I don't know if you guys are finding that, but also with the examples and the exercises at the end of the chapter, they get pretty high end too. So high end that I think I'm going to be using this in our data analytics program probably coming back to the same book and using some of the higher end exercises for those students. Okay, so they talk about this thing too. This is a programming tip, and I always tell people, you know, when you're new to this field and you're not comfortable with it, you're not comfortable with it. I mean, it feels kind of like an awkward thing to do, to break problems down to such minute detail to get them to work correctly. But they give you some tips here that I think are pretty important. So, you know, they kind of rail a little bit on Microsoft here right when they released the Vista operating system. You know, that one was not a very loved operating system. It was about as loved as Windows ME back in the 90s, and I don't know if you guys remember that one or not. It was kind of the same kind of thing. It was really a platform where they released an operating system that was kind of almost like a trial balloon for Windows 7 coming out. You know, Windows 7, everybody loved that one, but all the stuff that was new in Windows 7 was really actually, most of it was new in Windows Vista. And what people hated about Vista the most, I think, is the fact that it required a lot more from your hardware than XP did. So if you were running a so-so computer with XP and it ran just fine, and then Vista came out and you're like, what do you mean it won't run on my computer? So people were pretty frustrated from that standpoint. But they also put in a lot of weird stuff, and you know, I don't think they tested it as much as they could have. And you can see here that they thought they'd put it out in 2003, then 2005, then 2006, and then it finally didn't come out till January 2007. And even after all that rigmarole, 4 years of like, it's coming out, they found that they had a lot of issues. And I think one of the biggest issues that they had was like this thing called user account control. So like every time you went to install a piece of software, all of a sudden like these screens would come up and block you. And you know what, Windows still does that, but now we kind of have come to learn to accept it to some degree. But there's some issues, and looking back on it all, they did kind of figure out that, you know, we should have done a lot more testing. But look at the steps that they put through here. So they would design the program logic, and then they would develop the test cases, and that's what I was talking about with those if statements. You've got to be able to put in scenarios that are going to test every single possibility to make sure that they actually operate. All right, so once you've like kind of worked out the logical issues, then you can code it and fix your syntax errors, like whatever your code errors are, and then you run and test and debug it. So there's always like this, you got to plan, you got to test, you got to code, you got to keep testing, and it's a process, and you can't get frustrated with it because that's just how it goes. If you happen to write a program perfectly the first time, when it's a complex program, well, kudos to you, you're an anomaly. I'm just telling you that. The real programmers spend most of their time fixing the stuff that they've created to get it to do what they actually intended to do. The way that you minimize those hassles in the code process is by planning. Pseudocoding, flowcharting, testing your stuff logically before you even code. And I know it's a kind of a cumbersome thing, but it is the process. So as programmers, if you guys want to work in this field, that's going to kind of be your life, right? And I'm not trying to scare you or anything, but you know what? I think it's kind of fun. All right, so here we're moving on to section 3.7, where we do have, I think, what's a very important concept in programming. And the section's marked Boolean variables and operators. So this whole approach that we take here when we make these decision statements is we ask a question, basically. And we say, if whatever condition is true, then do this. But notice we're saying if it is true. So the whole concept of true and false falls thanks to this guy named George Boole back in the 1800s. And you see he's a pioneer in the study of logic, right? And he developed the Boolean operators, basically, the concept of true and false, in order to be able to execute something. It's kind of a bizarre thing. Like you'd think, you know, they would have figured it out logically before this point in time, but in order to make it as part of our mathematical structure, which really drives computer programming, he came up with this fact that we need Boolean variables and operators in order to do this stuff. So let's talk about this concept. So really what we're saying is that we can create variables with a name that can be set to a value of true or false. And notice they got an example there. So they have a variable called failed equals true. Right? And then they do an if statement. It says if failed, then you only execute it if failed has been set to true. All right, which kind of might be inverse logic, but let's say you do a test and they fail the test. If it's true that they failed the test, then I'm going to give them another test, or whatever the case may be. But that's the way that it reads. And so instead of like doing a comparison, like we might do here, this is a comparison. We're comparing one thing to another to see if it's true. And then we're also comparing this to see if it's true. Now this is what we call a compound statement, and we haven't talked about these yet, but this is a really important concept in programming. So what it says here, right, what the statement is we're trying to determine if water is in its liquid form, right? So if we're working with the Celsius scale, water freezes at 0 degrees. And at 100 degrees, it boils and turns into steam, so it's no longer liquid. So what this is trying to do here is cover both conditions with one statement. Because we want both of those things to be true in order to know that it's liquid. The temperature must be greater than 0, it's above freezing, and, there's the key word, and the temperature is less than 100. Now for that whole statement, the compound statement to be true, both conditions must be true. So if it's at 50 degrees, or anywhere between 0 and 100, you know that it's liquid, both conditions are true, so therefore the whole statement is true. All right? So they have this little table here, and we're looking at the leftmost part of it right now, and whenever you have a compound statement like that, and we use the keyword and, you have to remember, and requires both sides to be true, both statements to be true, in order for the whole statement to be true. So, if A is true and B is true, it's true. All right? If A is true and B is false, sorry, it's false. Because you could be greater than 0 and over 100, right? So you could be at 101, or at 100 actually, and that would be false. Water is not liquid. It could be the other way around. It could be below 0 or at 0. So A could be false and B could be true, but that's still false. Or both of them are false. Of course, that wouldn't be likely in this scenario, but both of them would be false, and the whole statement is false. The other approach is that you can use the keyword or instead, and if you use the keyword or, only one of the two needs to be true for the whole statement to be true. So if both are true, great, it's true. If only one is true, if A is true and B is false, still true. If B is true and A is false, it's still true. Only one has to be true. If they're both false, then it's actually false. All right? There's also a third operator in Boolean logic called not, which means the inverse. Now where that's useful is in a scenario like the one that we saw above where we set failed to true. So if we said not failed, what would be the value?
False.
False, right? Based on what was given above, right? So, so if A is actually true and we say not A, it's false. If A is false and we say not A, it's true. So it just does the inverse. I'm going to tell you, it's a little bit of a mind bender, and even experienced programmers run into issues with this stuff all the time. They think they have the logic right, then they realize that their signs are flipped, or it should be an or instead of an and. So don't feel bad if you don't latch onto it right away. It just takes practice. And you know what? That's another reason why you do the test cases, is to make sure that your logic is working right. Right? Because maybe you just flipped a sign somewhere, maybe you used and instead of or, whatever the case may be, but one way or the other, you have to get the logic right. All right, so they give this example here. And the weird thing is if you were doing math in this scenario. And this is what I always, try to do a comparison, because this stuff doesn't come from thin air. It's typically mathematicians that are figuring out this kind of logic. I'm going to bring my Notepad++ over and just kind of show you really quickly, like a statement like this one, like temp is greater than 0 and it's less than 100. If you were doing this in math, you know how you would write that? You would go 0, right? And maybe my logic's not even right. Is that right?
Should be flipped around.
Yeah, it should be flipped around. Very good. See, I'm trying to lead you astray to see if you're thinking. And really, assuming that temp of liquid water, with a little more description in there, that's more accurate, right? So liquid water would be greater than 0 and less than 100. And in mathematics, you're allowed to do it in one statement. In computer programming, sorry folks, you're not. You have to split it up into two statements. So if you're used to doing something like that in your math class, that doesn't work here. But this is the comparison mathematically if you're curious. And I think somewhere later in the chapter, the author does talk about that. All right. And they can actually flip this around too. So look at what they did here. If the temperature is less than or equal to 0, right, that means it's frozen, or it's greater than or equal to 100, meaning it's boiling, then it's not liquid. See the inverse logic there? Think about that. I know, and this is the kind of mind bender stuff. These are like little logic puzzles that you got to think through.
So when we're trying to figure out in between 0 and 100 for a liquid, it would be and, because it has to be greater than 0.
That's right.
It has to be less than 100. But when we do not liquid, we're kind of splitting it. I'm thinking of we're splitting it in two, where it's less than or equal to 0 and greater. So it could be on both sides.
Right. Yeah, and really what we're saying is, in essence, this statement is actually equivalent to the one above. But the one's just finding out that it's not liquid, and the other one's finding out that it is. But it's really covering the same range. They're kind of inverses of each other.
Yeah.
So there's the logic that goes with that. If you do have multiple conditions that you have to meet, and you try to logic that out, here an and would kind of be a sequential logic. So one condition has to be true and the other one has to be true to get to that statement. With an or, it doesn't matter which of the two is true or false. So an or would lay out like this. So it might hit the first condition and be false, but it still could be true and hit the statement. Or the first one could be true and hit the statement directly. And this is actually kind of a little bit of an indicator here of this concept called a short circuit. So we'll talk about that in a moment too. But basically what that means is when you have an or, if you hit the first condition and it's true, you don't really need to check anymore, do you? No, you don't have to keep reading the code. It's already true. It's interesting. All right, let's take a look at this little table, and I think this becomes pretty helpful. And they're showing you how this would evaluate. So this is kind of like a good way to test your brain on this stuff. And I'm going to give you a little fair warning. This stuff isn't on the midterm, by the way. Okay, which is a good thing. All right, so the first expression says 0 is less than 200. True, right? And 200 is less than 100. False. There's an and in the middle. One of them is false. The whole thing is false. All right? Go to the next one. Same statement. The one is already true, right? So the whole statement is true. 0 is less than 200. 200 is not less than 100, but it's an or. Only one condition has to be true for the statement to ring true. All right. Let's skip down a couple. and go to where it says 0 is less than x, and x is less than 100, or x is equal to minus 1. Woo. We actually have a compound statement here, so I want you to look at how they're breaking it down, and take a look at the next box. So they're saying that if 0 is less than x and x is less than 100, in that case, both of those conditions have to be true for that side of the equation to be true, but let's just assume that it is. Right? For the second half, or the condition has to be x equals minus 1. So only one of those combinations needs to be true. So if it was minus 1, it's true, the whole thing is true. If it's, let's say the number is 50, x is 50. Is 50 greater than 0? Yes. Is 50 less than 100? Yes. That's true also. The or is false, right? Because it's certainly not equal to minus 1. That's okay, the other side's true. Okay? See the catch there? And so the and, it says the and operator has a higher precedence than the or operator. So whenever you see an and, you have to process that first. And you can write complex statements like this. And the reason that people do that is because you can cover all the scenarios and address it with one line of code afterwards. Instead of writing multiple lines of code to cover all the scenarios, if you set up your logic statements correctly, you can kind of cut down on the amount of code. Okay, let's look at the other one. Not 0 less than 200. Well, 0 is less than 200, which is true. But we want the opposite, so it's false. Got that? It's kind of weird. Frozen equals true. Value is frozen, which is true. Yeah. That's what they're trying to show you there. Because you can set it to a variable. Right? All right. Frozen equals false. Are they equivalent? Yeah. All right. So I know those are a little bit of a mind bender, and if you want to practice with those, they have some really nice little exercises here you can play with. And I suggest that if you're completely brand new to programming, you might want to do that. Right? They cover a couple of these little common errors, and I'm not really too worried about those. You can read those. I do want to talk about the chaining of relational operators, which is the thing that I was just mentioning. So, you know, the point again was that in mathematics, what we typically do is something like this, right? We chain the value. So if the value sits in between 0 and 100, this is how we would list it. Then this would include 0 and 100, right? So value, but if we wanted to do it in programming code, we would have to say value is greater than or equal to 0 and value is less than or equal to 100. There's no other way to do it. You have to write it as two separate statements with an and, period. Okay? Here's that other topic of short circuit evaluation. So once again, with an and statement, since we have to test both conditions before we can evaluate to something being true, both must be processed. However, with an or, you know, if we put an or in its place, if the first condition hits true, we're already done processing. We don't need to keep going. All right, so that was kind of the topic there. All right, moving on. All right, so now we're on section 3.8 about analyzing strings. And you know, we do, like a lot of our comparison stuff when we start out, we start thinking first with numbers and are they equal or greater than or less than. That's just kind of what we tend to do. And even if we throw in ands and ors, we're still thinking numbers, right? Because numbers are really logical, you know. Then we start to throw in the Booleans, which is the true false, and then we realize that all those test statements that we're doing are really resulting in Boolean values of true false. And then we get to the point where we need to deal with strings. And strings become a little bit more tricky. So, for example, they show the name like John Wayne. And we might be looking through a document and we might do a search. So that's actually a good example. We do a search for something on a document and I'm searching for Way. That is part of John Wayne. So if I did a search, that would highlight, right? So that is an expression that is part of that string. And there actually are methods built in to Python that allow us to do a whole bunch of different things with strings. So for example, they start moving down here and doing this example. So it says if a dash, and just notice how it's in double quotes, not in name. And you know what? You can do that. So we assume that name is a variable and not is a keyword saying the inverse, and in is a keyword implying is it contained within. So dash not in name, so there's no dash in the name, that name does not contain the hyphen. So it actually can search for the dash, validate that it's not present in that variable, and then give us that error message. Here's another example. This one is file name. We assume that's a variable that's been populated. And then the method, and notice how the method is added here. It's with dot syntax, and I think we saw a little bit of this earlier, but that method ends with, and then inside double quotes we have dot HTML. So if the file name is an HTML document, it'll ring true, and then you will be able to say this is an HTML file. So there's lots of these different tools built in, and here's an example of some of them. So one of the tools that you can use is this thing called substring in S. So if I had the John Wayne example above, I would say W-A-Y, in quotes, substring in S, which might be equivalent to John Wayne, and it would look for that, and if W-A-Y was contained inside of John Wayne, it would come back as true, and then you could execute whatever statement you have. The other thing you can do is you can also count the number of, in this case, non-overlapping occurrences of a substring. And this is all about substrings. We're looking for, for portions of strings. And this should really trigger in your brain whenever you do a Control F on a document and you start typing in a search term. This is exactly the kind of stuff that's executing in the background, folks. And every time you add a letter, the substring gets longer, but we're searching, right? So you might find that substring in your document, and the count method does what? It indicates how many times it's coming up. So all browsers, have a Control F find feature, right? So I just did Control F. It brought up a little box there. And so if I was searching for Way, for example, not only finds it on the page, hopefully, right? But it also indicates how many are there. So how do you think it's doing that? It's counting it. It's running a method just like that. It's not being done in Python. It's actually being done in JavaScript. But the concept is really the same in that language. We can also check to see if a word ends with a substring. And that's what we did with the HTML file. We also have the find. And then the find just gives us the first occurrence of where it's found, basically. We can also do starts with. So they can use these little techniques here to check a lot of different things about strings. But hold on, there's even more with strings. Strings have lots of special little tools that come with them. And so in this case, they're checking to see is lower. And as the message indicates, that method checks to see if it's all lowercase. Can you probably guess it just probably is upper? Yeah, absolutely. Another one here is alpha, and what that checks to see if it's alpha characters, A through Z, capital or lowercase, and if a number pops up, then it would be invalid. But if it's letters, upper or lowercase, then it would ring true. So here's an example of some really common string methods that are available in Python for checking things. So you can check to see, is it a number, letters or digits? Alnum, right? That's kind of weird. Because remember, numbers, if they're put inside of quotes, they're still numbers, but we can't do math with them. And in that case, they're treated as strings. So it checks to see if they're string numbers. That's what that one does. Alpha we just saw. And then, is it a digit? Well, if it happens to be a number, then it would ring true. Is it lowercase? Is it a space? Is it uppercase? Those are all things that are built in. So those are just methods that we can apply to any variable or object that is a string. All right? That can be pretty useful when we're doing things like alphabetizing, checking to see if like the input that somebody is giving us is valid, right? If you say, give me your phone number, and they're typing in their name, that's a little bit of an issue, you know? So you don't want to store a name in a phone number field, especially if it's going into a variable that's set to a numeric data type. It can be problematic. So that's some of the reasons why we do that. When you do start to analyze strings, they do have this handy little chart here, once again, that shows how all these different methods and Booleans work when we're talking about strings. So I think we kind of looked at this already, right? Like John and John are equivalent on the first one because they both have a capital J. On the second one doesn't have a capital J, so that's false. Is John less than John? Well, okay, so that's a whole field of study right there. The alphanumeric characters actually have a whole collection of values that go with them that convert all of them into numeric values to do comparisons. And that's a whole field of study. So if you really want to learn about that, you can go to the special topic 3.2, and then you can actually go and find all the ASCII key code values that things have. And yes, you can do those kind of comparisons. But typically, you probably won't find yourself usually doing that, but you might. All right. All right, so they go on through more examples. John in Johnson Johnson is false because John does not literally appear that way because it's a lowercase j. Right, if you're wondering. Here we set a variable to the name John Johnson, and then we see ho not in name. Yeah, there's no HO combination. There's an O and an H, but not an HO. So not in name, that's true. It's not in the name. You see the logic here, folks? All right. So now that we have the variable set, we count the number of OHs, and there's two. 1 and 2. Can we find OH? Yes. The index value of the first occurrence is 1. First position is 0. Second position is 1. That's what that means. So that helps you locate it in the structure. We find HO. If it basically, it's not going to find it because it's not there. So instead of, giving you false, it says -1, which indicates that it's false. That's kind of weird.
So
yeah, it's a little weird.
If we have something where it comes up with OS instead of SO on Johnson, it will also come up as false?
It would come up as -1 because that particular method, the false output is a negative number. And that way you can write code to check for that negative number to know it's false. That's basically how it works. Starts with John, false, once again it's a lowercase j. Is there a space?
I think so.
Yeah.
Between John and Johnson.
Yeah, I think so too. But what does that method actually do? Let's go back and look at what it says. Returns true if the string S consists only of white spaces. Does it consist only of white spaces? Yeah, false. So what they're checking for example, is did somebody just type in a bunch of spaces? Is it just a blank field? Okay. All right. Is this literal number, is it a digit? True. Right? This would come up false because the negative sign is not read as a digit. That's an alpha character, basically. All right, that's the example on that, folks. Play with the examples here at the bottom. Help you get a little clarity on how to make it happen. All right, and now we're moving on to the last section we're going to cover in this chapter, and it's about input validation. All right, so we need to talk about this as a concept, and this is really important. This is something that you learn in just about every programming and markup language that you have to learn. So like HTML people, you know, those of you that are in that class, we'll get to a chapter pretty soon on HTML forms, and that's a concept we learn there as well, is, you know, you give users a way to interact with your program and allow them to enter information, but you have to make sure that the information that they're entering is appropriate for what it's going to be used for. So if I ask for a user, hey, enter an integer, and then you type in a floating point number, that's a problem. Or more of a problem, if you ask for some sort of a number and then they give you a name, that's even more of a problem. So that's why input validation is important. All right, so they go through a couple different scenarios here, but the whole point is, how do you deal with input that is inappropriate? So for example, they go back to that elevator problem, and they'll say, you know, let's say you went into an elevator, and instead of like having a preset button that said, you know, 24, that you had to like type on a keypad what floor you wanted to go to. And you typed 13, but 13 doesn't exist as a floor. So that's an invalid input. How are you going to handle that? A really simple way to handle it would be the first example there. If floor equals 13, error, there is no 13th floor. Try again. All right? All right. So, and how about this one? Here's how you ensure that the user doesn't enter a number outside the valid range. You'd write an if statement that kind of governs both scenarios. So for example, they would have to enter a floor that is above 0, right, because there's no 0 floor, or, you know, maybe some places have a ground floor, but usually they call that the first floor. And the building only goes up to 20 stories, or maybe 19 stories. And how would you set up a scenario to check for it? So if the floor is less than or equal to 0, or the floor is greater than 20, right, that still includes 20, right? It sure does. And then your message would be the floor must be between 1 and 20. So if somebody tried to be clever and type in 21, I'm going to go to the roof. You go on 21, right? Not happening. The elevator only goes up to 20. So that's a primitive, that's what I call a primitive way to check for valid input. We will learn more sophisticated methods as we go further into the book, and those will relate more to exception handling. Because here's the problem. If I'm asking somebody for the floor, we assume they're intelligent enough to type in a number. Right? This is the whole thing, right? Because, all right, what floor are you going to? 13. All right? But what if the person typed out 13 as a word? And they try to go into an integer. You know what? It would fail. We would have an exception that would happen. That's when the program just stops working. So when you don't have proper exception handling built in, we haven't learned that concept yet, but you can set up scenarios so that when a person puts in the wrong information, it doesn't kill your program. Right? That would be pretty bad on an elevator. What floor are you going to? Apple pie. Elevator stops working. You know, that would be really bad. So that's not like a scenario that you want. But at this point in time, we do need to make sure that whatever they input, and this is what you would have to do writing your program, is you do have to convert it to an integer in order to work in the code, right? So Sometimes it's not a bad idea when you're prompting for user input and you don't yet have exception handling put in, that you are very specific. Enter floor number as a number. You might even have to get, please don't type 11, type 11, You might even have to go to the trouble of explaining it. And that's why we eventually learn how to do exception handling. So they go through an example here on how to do that. And then here's an example, like if you're asking for somebody to input a letter. So you're giving them a very specific instruction, and this is what I would consider good practice. It says, please enter S for single and M for Mary. And then notice that when they received the input, assuming the user did it correctly, then we check it, and then, you know what? Maybe they had caps lock on. Are you going to just check for lowercase s, or are you going to check for both? So in this case, we're checking for both. It says if marital status is S or capital S, either one could be true, and the whole thing is true. We assume they mean single. See the logic? Else, if the marital status is lowercase m or capital M, either one could be true and the whole thing is true, then we do that second statement. Otherwise, you print an error. What the hell's wrong with you? It must be S or M. Okay, so you give them something that's useful, but that's kind of like the catch-all there, and that's a thing. So as we move into the next chapter, when we get to looping, if they didn't answer the right thing, we then could reset them and make them go back to the question again and ask it all over again, and they don't get to leave that loop until they give us the right answer. See the logic. All right. So they give a number of different examples about how to do that, and I think I've said enough about it already. Follow through these examples and play with them. And then I want to talk about one more concept real quick. This one. Okay, so sometimes instead of allowing a program to crash, you can actually exit gracefully. Because crashing causes problems on computer systems, right? Programs really shouldn't crash, because what happens when a program crashes is it leaves little remnants in memory. Now, Python happens to be a language that does have what we call automatic garbage collection. And if those of you learning Java right now, maybe you've heard that term before. So what Java does for you, for example, is like if a program crashes and you have all these values stored in variables, it goes through and it cleans them all out. If you learned a traditional programming language like C, like I did way back in the day, and your program crashed, all that stuff is still sitting in memory. And you know what happens if you do that a bunch of times? It fills up your memory, and all of a sudden you can't run stuff. So like in the C programming language, you have to know to release all your variables. So it's kind of a different level of programming. Modern languages like Python do automatic garbage collection. So if it does crash, the variables do go away, but it's still considered better practice that instead of letting them see the exception message, that you gracefully exit the program. So in order to do that, you can just run this simple little library here. You do this little import statement. So from sys, import exit, that would go way at the top of your program. And then if you ask a user for some input, what's your response, yes or no? Right? Z, right? They press Z instead, or whatever. So instead of crashing, we just set up a scenario where it says if the user response is N or the user response is Y, those would be true. But if it's not one of those, then exit the program with a message up on the screen. That works best for console programs like we're writing right now. Okay, so that's going to end my lecture part here. Let's take a 5-minute break and then we'll come back and code.